Welcome to the Explainer, everyone. I am absolutely thrilled to take you on a seriously high-speed journey back in time today. We're going to be exploring the prehistoric sprint, uncovering who the true speed demons of the Mesozoic era actually were. So get ready, because we're about to completely shatter some of the biggest illusions you probably have about the ancient world. Section 1. The Dinosaur Speed Myth. Hollywood versus reality. Okay, let's dive right into this. Our core theme today is all about contrasting the pop culture expectations we all grew up with against grounded, scientific reality. Imagine just for a second that you are facing down the fiercest predators of the Cretaceous period in a foot race. We've all been taught by Hollywood to fear the terrifyingly fast, pursuit predator T-Rex and those incredibly agile, cheetah-like velociraptors. But could you actually outrun them? Well, the answer might completely shock you.
You've probably heard the most famous claim out there, the velociraptor, which, by the way, was actually only about the size of a turkey, supposedly used its lightweight frame and strong legs to reach these staggering speeds, estimated to be around 40 miles per hour. That's over 60 kilometers an hour. But hold on to that thought, because cutting-edge anatomical science is about to flip this popular assumption totally on its head.
Section 2. Reading the fossil footprints. Measuring the past. Before we go totally debunking myths, we need to understand the tools scientists use to figure out how fast these animals were moving. When paleontologists find fossilized tracks, they do a bit of brilliant mathematical detective work. First, they measure the length of a single footprint. By multiplying that length by 4 or 5, they can actually get a highly accurate estimate of the dinosaur's hip height. Then they measure the stride, the distance between the imprints of the same foot, and divide that by the hip height to get a ratio. This ratio plugs right into a formula known as Alexander's equation. And what's absolutely fascinating is that when we do this math, most of the dinosaur trackways out there actually show them walking, not running.
Section 3. The leg length equation, how anatomy dictates speed.
Now, what's really interesting here is what happens when footprints just aren't available. Scientists have to look directly at bone anatomy, and that introduces a pretty complex concept called allometry. Basically, you can't just look at limb length in isolation. Think of it kind of like scaling up a model airplane. As an animal's body mass increases, its proportions naturally have to change to support all that extra weight. This means smaller juveniles generally have proportionately more elongated lower legs than the massive adults of the exact same species. It's a tricky variable, right? Researchers have to factor this out before they can figure out if a dinosaur truly evolved for speed. To solve that scaling problem, researchers plot out the data. When comparing 53 different theropod species, researchers look at femur length, which acts as a stand-in for body mass, against lower leg length. And this brilliantly illustrates how a power curve run through that data establishes the normal, expected lower leg length for a dinosaur of any specific body size. By comparing a dinosaur's actual leg length against that expected curve, scientists calculate what's called a cursorial limb proportion, or CLP score. A positive score means those legs were adapted for running. A negative score means the exact opposite. Now, remember that 40-mile-per-hour pop culture claim about the velociraptor? Well, anatomical studies show that dromaeosaurs, which includes the velociraptor, actually had negative CLP scores. Yep, despite the movie magic, their true anatomy tells us they were not highly adapted for sprinting at all. Section 4. Tyrannosaurus rex. Just a walker? So if the raptors weren't the speedsters we thought they were, what about the ultimate apex predator? Let's move to the science and see how this builds a totally different picture. In the past, older models just looked at the T-Rex's massive muscle structure and relatively long limbs and predicted blazing fast speeds, up to 20 meters per second. But the new approach uses multi-body dynamic analysis, or MBDA. This isn't just looking at muscle mass anymore. It's a multi-physics simulation that factors in the actual structural strength of the skeleton itself. So the crucial point is that a multi-ton animal experiencing an aerial running gait, where both feet leave the ground, generates incredible force. These dynamic simulations prove that for a massive T-Rex to truly run, its leg bones would experience skeletal stress exceeding 150 megapascals, and the absolute maximum limit for living bone tissue is well below that threshold. Paradoxically, the T-Rex's long, graceful limbs actually mechanically limited it strictly to walking gaits, simply to avoid completely snapping its own bones. Section 5. The true prehistoric sprinters. Meet the real track stars. That raises an incredible question. If the terrifying T-Rex was restricted to a brisk power walk, and the velociraptor wasn't built for a high-speed chase, who actually holds the prehistoric track record?
Enter the ornithomimids. These were the true sprinters of the Mesozoic. They had ostrich-like, feather-covered bodies, large eyes, and incredibly slender limbs perfectly optimized for rapid locomotion. You have Ornithomimus, the literal bird mimic, estimated to hit 45 miles per hour. You have Gallimimus, a toothless omnivore hitting speeds up to 56 kilometers per hour. And we have Dromaeosaurus, with a remarkably lightweight build, pushing the speedometer to an unbelievable 50 miles per hour. The contrast here is just absolutely staggering. While giant, terrifying apex predators were lumbering along at walking speeds just to protect their skeletons, these agile, bird-like herbivores were absolutely blazing across the landscape at up to 80 kilometers per hour. They were leaving everyone else far behind in the dust. Without a doubt, they're the undisputed speed demons of their era. Section 6. Science rewrites the race, moving way beyond the silver screen.
It's absolutely fascinating to look back and reflect on how much the science of paleontology has advanced, taking us far beyond cinematic illusions and into the real physics of the ancient world. Let's quickly summarize how we got here. By combining straightforward footprint math with deep anatomical analysis, we successfully dispelled those Hollywood myths. By calculating allometre and CLP scores, we revealed that raptors weren't the runners we assumed they were. And by deploying cutting-edge multi-body dynamic analysis, we proved that giant theropods like T-Rex were bound by the very rigid laws of skeletal stress. Modern science has completely rewritten the dinosaur race.
We've completely dismantled the myths and uncovered the real track stars of the Cretaceous. But it really makes you wonder, doesn't it? With our pop culture assumptions so thoroughly busted by biomechanics and fossil math, what other incredible, mind-blowing prehistoric secrets are just waiting in the ground to be uncovered next?